All right, good morning and happy Monday. It is Monday, March 30th, of course. And today we're going to start our new section on exponential functions. I'm sure you guys have heard enough about exponential growth lately. As the Google Classroom post says, please complete that Desmos activity as your attendance check-in for the day. So, the most important thing about exponential functions is that we have a function. It's a function where we have x in the exponent. So here you can see all these examples. X is in the exponent. So, I could have x minus 1 in the exponent, or I could even have x plus 5 in the exponent. As long as x is in the exponent, we're not really going to work with anything like this for today, but the most important thing here is that I've got x in the exponent. Something that's not an exponential function is when this exponent is not x. We can see here I have x and I have an exponent, but when that variable is not up in the exponent, when your variable is not the small number up here in your power, this would be an example of something that is not an exponential function. So again, we're always looking for something that is having that variable up in the exponent. So I'd like you to classify the following as exponential or not exponential. And if you want, you could, write these on a separate piece of paper. Probably wouldn't take up too much space. So let's look at this first one here. I do have a power, but do I have a variable up in my exponent? And the answer there is no, so that would not be an exponential function. What about B? Well, let's look at my exponent. I do have an x there, so that variable is in the exponent. So I'll say that is an exponential function. And here I've got an exponent. But what is in that exponent there? What's up there in the power? Well, it's not x. There's no variable in the exponent. The variable is down here. So even though I do have an exponent, that exponent is not x. What about here? Well, let's look in my exponent. And indeed, that is an x. There's my variable there. So that's an exponential function. And these last two, I do have an x, but is it in the exponent? And the answer there is no. And f, y equals 0, doesn't even have any exponent. I don't see an x there at all. Okay. So we can identify exponential functions by, whether or not there's an x in the exponent or not. We can also identify exponential functions by their tables. So a linear function is going to grow at the same rate every single time. So, this y column might go up by, 2 or 4 or 5 or whatever it is every single time. It'll change at the same rate. Whereas an exponential function is not going to do that. It's going to be multiplying these y values by the same thing. So here's an example of an exponential function. Let's see, what is my number being multiplied by every time? Well, what do I need to multiply 1/3 by to get 1? Or how many 1/3s are there in a whole? Well, there are 3/3 in a whole, so I'm multiplying this by 3. And 1 times 3 is 3. And this is where it gets kind of tricky. 3 times 3 is 9. And 9 times 3 is 27. So you can see we're multiplying by 3 every single time. So I'm getting bigger and bigger and bigger. Here I would be adding 2/3 and adding 2 and adding 6 and adding 18. So I'm clearly not going up by the same amount every time. I'm not adding the same amount every time. But I am multiplying by the same amount every time. And we can think of this like 3 to the first power. So 3 to the first is just 3 times itself, 1 time. And then here, 3 to the second, 3 times 3, and 3 to the third is 3 times itself, 3 times. So that's just to get an idea of, here I added another 3, or I'm sorry, I multiplied by another 3. So I multiplied by another 3, 3 to the fourth, I would be multiplying by yet another 3. So that's what I'm getting at when I say we're multiplying by 3 every single time. We keep multiplying by another 3. And here's an example of a function that's not exponential. And how can we tell? Well, I'm adding 2. And then from 0 to 2, I would add 2. And from 2 to 4, I would add 2. And from 4 to 6, I would add 2. So we can see that change there, it's a linear function. And the reason I know this is a linear function is because I'm adding the same thing every single time. So it's growing at the same rate all the time. I'm adding the same thing every single time. And this one I'm telling you on the right is exponential. So let's see, how is this one changing? Well, from 1/2 to 1, what am I doing to go from 1/2 to 1, or from 50 cents to $1? Well, I would have to multiply that by 2. And then how do I go from 1 to 2? Well, I could multiply by 2 again. And from 2 to 4, I could multiply by 2 again. And from 4 to 8, I could multiply by 2 again. And, if we check this out, just like we did in our first table, 2 to the first is just 2 times itself 1 time. And then we've got 2 to the second equals 2 times 2. And 2 to the third power equals 2 times 2 times 2. So you can see that we keep multiplying by another 2 every single time we go down this table. And that matches up with our exponential function. Well, it's 2 to the x. So I keep multiplying by another 2 every time. And again, we can tell this is exponential because in my exponent, I have the x, or the variable. And here, this is not exponential because I don't have that x in an exponent. All right, why don't you guys pause the video here and determine if these last four tables are exponential or not exponential. Are you multiplying by the same thing every time? That would give me exponential. Or are you not multiplying by the same number to go from one y value to the next? You could say multiplying or dividing depending on what direction you're going. You know, am I multiplying or dividing by the same thing? Or is that not happening? Maybe I'm adding by the same thing every time. Check out these last four here, and then you can unpause the video and we'll see how it went. Well, for A, I started with 1/7. How do I go from 1/7? 1/7 times what gets me down here to 1? Well, how many 1/7? How many sevenths are in 1? Well, that would be 7 sevenths would get me 1. So I'm multiplying by 7. And then 1 times what gets me 7? 1 times 7 gets me 7. And 7 times what gets me 49? Well, 7 times 7 is 49. And let's check this very last one just to make sure the pattern still holds. 7 times what gets me 343? Or you could think of this as 343 divided by 7, just to check, does that get me 49? And in fact it does. So another avenue you could take is you could go this opposite direction and you could divide each number by the number above it to see if you keep getting the same number. And if you do, then you know that it's an exponential function. So this one is, I keep multiplying by 7 each time. So this would be y equals 7 to the x. And you know what, let's try that last approach here. Let's see, 49, if I divided 49 divided by 38, what would I get? 49 divided by 38 gets me, well, that's 1.289. Okay, now let's see, if I divide 38 by 27, 38 divided by 27, do I get the same number? 1.407. Well, these are not equal. So if these two numbers are not the same, if I'm not multiplying by the same number every time, then I know that this is not an exponential function. And you know what, let's just take a moment and see if we can identify some other pattern. We know it's not exponential. Let's see if we can identify some other pattern. Maybe I'm adding. Let's see if that would work out for me. So 5 plus what would get me 16? Well, what's the difference between 16 and 5? That would be 11. And 16 plus what would get me 27? Well, 16 plus 11 would get me 27. Or 27 minus 16 gets me 11. 27 plus what gets me 38? Or 38 minus 27 is what? Well, I'm adding 11 again. And then I'm adding 11 again. So this is not exponential, because I'm not multiplying by the same number like I did over here. But it is a linear function. So not exponential, not what we wanted, but we can still look for patterns. And our last two here. What pattern is going on here? What's happening to all these numbers as I go down my list? Or you could even look at what's happening as I go up my list. So take a second, look for that pattern there. What do you notice? Well, to go from 16 to 8, I would divide by 2. Or multiply by 1/2. What about from 8 to 4? Would that still work? Well, yeah, I could still divide by 2 or multiply by 1/2. And from 4 to 2, yep, that pattern still holds. And we should always check all of our options here. From 2 to 1 still seems to hold. So I'd say, since I am multiplying or dividing by the same thing every single time, then I know this is an exponential function. And since I'm multiplying by 1/2 every time, or dividing by 2, I can say that my function is y equals 1/2 to the x. And, we'll talk about this a little bit later if we get to it, but what I really want you to focus on is, am I multiplying or dividing by the same thing every single time? That's really what our focus should be. That's what's going to tell us if I have an exponential function or not. And last up here, let's see what's happening. Well, from 1 to 0 to -1 to 0 to 1. What patterns do we notice here? Well, what's happening? I subtract 1 to get from 1 to 0. And then from 0 to -1, I subtract another 1. But then I start going from negatives to positives. So I actually add 1, and then I add another 1. So an interesting pattern, definitely. But in this pattern, am I multiplying or dividing by the same exact number every single time? And the answer there is, no, I'm adding. So this is not exponential. Not exponential. I'm not multiplying by the same thing or dividing by the same thing every single time. So please finish that Desmos task for your attendance today.